Today's topic is translating expressions, going from verbal to algebraic. Before we even look at anything, let's break down what we're going to do. Verbal means words, and algebraic is math symbols. So we're going from words to math symbols. Okay, let's get some background information and vocabulary written down first. Expression. An expression is a phrase that contains one or more symbols and numbers and does not contain an equal sign. If it had an equal sign, it would be an equation. Expressions are just the mathematical form. So an example would be 3x plus 6. Not an example would be 3x plus 6 is equal to 9. It is not an expression because it has an equal sign. There are no equal signs in an expression. Next, in your own words, you could fill out on your own. A variable. A variable is a letter or another symbol that represents a number. So let's look at an example. 3 times the number of students per class. Let S represent the number of students in class. We don't know how many students there are. Since that's an unknown number, we're going to let S represent the number that we are going to replace. Not an example would be 3, 4, 5, 6, and 7. A number is not a variable. A variable, again, is a letter or a different symbol that represents a number when we say it. A constant. A constant is a number that never changes. It is added or subtracted. Let's look at the example 3x plus 8. In this example, 8 is the constant. X would be the variable. Not an example. Let the red represent the constant. So in this example, x is saying is a constant. No, we know that is a variable. That brings us to our parts of an algebraic expression. An algebraic expression is broken up into terms. Terms is the number of pieces that make up an algebraic expression separated by operations. An operation is our math action words. Again, those are addition, subtraction, multiplication, and division. So we have our operations, which are adding, subtracting, multiplying, or dividing. So we have a coefficient, which is the number in front of the variable, in front of the variable. Then we have the variable, which is a letter or a symbol. In this case, it's a letter that represents a different number. We have our operation, and then we have our constant, which is always going to be 2. No matter what, our number there is going to be 2. Our variable here, depending on what we let it be, it could be a 5, a 2, a 3, a 4, or 5. It's going to change. It varies depending on our answer. Before we start going from verbal to algebraic, we're going to have to look at math key action words. So for addition, things that generally mean addition are plus, sum, more than, take note of that, stars, that means something, we'll go over it later, increased by, in all, and together. Some for subtraction are minus, difference, less than, again take notice of the stars, subtract, decrease by, or less. For multiplication, we have times, product, multiplied, each, depending on the situation, of, and factors. Division, we have divided, quotient, per, again, depending on the situation, rate, ratio, and separate. Please write those down. Just like when we try to solve our word problems, when translating from verbal to algebraic, we need to box in the keywords, underline the question, circle the numbers, and cross out any unnecessary information. Okay, let's jump into examples. So, we have the sum. Sum is one of those key action words that we described of 6 and a number. Okay, so now we have to go back and say the sum. The sum means add. 6 is the number 6, and a number is going to be represented by n, because that means we don't know the number yet because they didn't tell us. It is a variable of n. So we have the sum of 6 plus n. We're adding 6 and n. Our answer is 6 plus n. Next, a number. So a number is a number, so we're going to circle that and call that n. Decreased, we're going to box that in because that's one of our math action words, and it means subtraction, by 5. 5, again, is a number, so we're going to circle that. So our expression becomes n minus 5. Moving on. 10, we're going to circle that number, times, box in the keywords, which means multiply, and a number, again, we could call that number n. So we have 10 times n. Okay, 10 times n could be represented a few ways. We could have 10 with the dot n. Remember that dot means multiply. We could have 10 just next to the number n, so it looks a little cleaner, because that means 10 multiplied by whatever number we make n. Or we could have 10 parenthesis n. Remember, a number next to the parenthesis means that you're going to multiply. Our next example, the quotient. We're going to box in quotient and put our action word above. The quotient means divide. We're dividing t and we're dividing 5. Since t comes first, we had to put that first. T divided by 5. Remember, we could represent division with a fraction. So if we represent it with a fraction, we have to put t on top because it was said first. T divided by 5. Okay, every time you see the words per and each, I want you to put a star over it when we're going from verbal to algebraic. Let's look at an example. Write an expression that shows that Miss Filazzo buys S shirts. Each, so we're going to star each shirt costs $5. Okay, so we need to know how much money did she spend. We're going to say 5 times S. In this case, each means multiply. So 5 times S. If each shirt is S if each shirt is $5, depending on how many shirts we buy is our total, or 5s. We wouldn't divide here because we want a total, and if we're buying multiple, we have to multiply. Okay, let's look at the second example. Write an expression to show that Miss Flowers runs 2 miles per day. So we have 2 miles times the amount of days. Do you see how we have an x, which means multiply, and then our d, which is our variable? Doesn't that look a little confusing? So make sure we write it without anything. So 2d, so 2 multiplied by d. 2, again, is our amount of miles that I run, and the d is the day, so depending on how many days, 2 times a certain amount of days will get me my answer. Lastly, every time you see the words more than or less than, and if you see the word from, you're going to think of switching the order. You could create a wave to remember. So let's look. I have 3, circle our number, games less than Chris, who is safe. So less than, we are going to draw a wave. 3 less than Chris. Do you see how it goes a wave? So instead of doing 3 minus C, you're going to do C minus 3. Next, we have 6 more than, so we have to create our wave, double a number. A number is n. Remember, double. If you're doubling something, it's multiplying by 2. Okay, so we have 2n more than, which was our plus 6. And our last example, 5, circle the number, subtracted, which is minus. But we have that from right here, a number. Think of the wave. Subtracted from a number. So n is underneath that wave, so we're going to do n minus 5. Remember, anything underneath the wave comes first. Okay, good luck. I'll see you tomorrow.